Good morning. This is the math department for GS Amjad High School. Today we start the chapter sequences part 1. In this session, we will discuss the definition of a sequence. We will talk about special sequences, arithmetic and geometric sequences. By the way, this is a revision session about what you have studied last year. The first question is, how is a sequence defined? As you know, a sequence is a set of numbers, of values, forming a certain pattern. These numbers are related to each other. A sequence is well defined if we can list all of its terms, or if we can find any term, like the first term, the second term, the 10th term. You have studied last year that a sequence may be defined explicitly. What does that mean? A sequence can be defined by expressing its general term un in terms of n. This is exactly as we define functions. Example, consider the sequence un defined by un equals n plus 2 over n squared plus 1, where n is n. It's exactly similar to f of x equals x plus 2 over x squared plus 1. But here the domain of the function or the domain of the sequence is set n, or it could be a part of n. When we say n, small n is in n, this means that the first term has to start with 0. So the first term is nothing but u0. So here I'm asking you to calculate the first two terms, u0 and u1. Then I want you to go directly to the 11th term, u10. U10 here is the 11th term, or the term with rank 11, since we've started with U0 and not with U1. A sequence may be starting with U1. To find U0, you simply replace n by 0, exactly as in the function you are replacing x by whatever. You calculate f of x. Here it's the same. So U0 is 2. So the first term is 2. So the term with rank 1 is 2. So U0 is the term with rank 1 in this particular example. For n equal 1, you are getting the next term or the second term. U1 is simply replacing n by 1. It will be 1 plus 2 over 1 squared plus 1, which is a 3 over 2. For n equal 10, so if you want to calculate U10, you simply replace n by 10. So U10 will be 10 plus 2 over this, and that's 102 over 101. So when the sequence is defined explicitly, you can calculate the term with any rank. So if you want the 100th term, and in this case, the 100th term is U99, you simply replace n by 99. If you want U1000, you replace n by 1000 directly, and you will get the term directly. But a sequence may be defined in another way. A sequence can be defined recursively. What does that mean? A recursive sequence means that the sequence is defined by a relation between the consecutive terms, like un and un plus 1. So you define a term in terms of the other term, usually the previous term. But here you need to know at least one of the terms, usually the first term. A sequence can also be defined by its first term and a recursive relation that links two consecutive general terms. Example, consider the following sequence defined by U0 is 1, Un plus 1, which indicates any term, is 2 times Un squared, which is 2 times the previous term squared, plus n plus 2. Calculate U1, U2, and U4. To calculate U1 or U2 or U4 or U whatever, you need to use this recursive relation. To find U1, you should replace n here by 0. Replacing n by 0, this recursive relation will be U1 equals 2 U0 squared, but U0 is 1, plus 0 plus 2, and consequently U1 is 4. To calculate U2, you simply replace n by 1. So u2 will be 2u1 squared plus 1 plus 2. But u1 is already calculated to be 4. So it's 2 times 4 squared plus 1 plus 2, and that's 35. Now I want you to calculate u4. By the way, you cannot go directly to u4, because if you replace n by 3, you will get u4 equals 2u3 squared plus 3 plus 2, but you don't know the value of u3. That's why you need to find u3 first, then you go to the next term, which is u4. So you cannot jump from u2 to u4. This is a big difference between recursive sequences and explicit sequences. In the previous example, we went directly to u10 by replacing n by 10. Here you need to find the previous term to go to the next term. So for n equals 3, u4 will be 2u3 squared plus 3 plus 2, and you will get the answer. There are two special sequences that you have studied last year. What about the arithmetic sequence? It's a very special sequence. A sequence is said to be an arithmetic sequence if the difference between any two consecutive terms is equal to the same common difference. In general, un is an arithmetic sequence if any term minus the previous term is d, where d is a common difference. For example, if you consider the sequence 1, 4, 7, 10, and so on, which means you are adding a constant, which is a 3. Which of the following sequences is an arithmetic sequence? Look at this sequence and look at that sequence. Start with the first sequence, un equals to 3n plus 5, and find un plus 1 minus un. If this difference is constant, then yes, the sequence is arithmetic. un plus 1, how we get it? By replacing n by n plus 1. So you will get 3 into n plus 1 plus 5. Minus un, which is a 3n plus 5, so minus 3n minus 5. Simplifying, you will get 3, which is constant independent of n. When I say constant, I mean independent of n. It doesn't need to be a natural number. It could be minus 0.7, let's say. So the common difference is 3. By the way, if you try to list the few terms, or the first few terms of the sequence, u0 will be 5. The next term will be 8. The next term will be 11. You are clearly adding a constant, which is a 3. Considering now the next sequence, calculating un plus 1 minus n, don't forget to calculate un plus 1. You go to the sequence un and you replace n by n plus 1. So it's n plus 1 all squared plus 2 minus n squared minus 2. Simplifying this, you will get 2n plus 1. An expression which is dependent on n, which means it's not a constant. So this sequence is not arithmetic. By the way, to prove that a sequence is not arithmetic, it's enough to list, let's say, few terms and see that they don't have the same common difference. For example, here the first term is 2. The next term will be 3. And so on. If you get the u2, you will get 6. So you're not adding a constant. Clearly, this sequence is not arithmetic. By the way, whenever the general term is in this form, a n plus b, then for sure it's arithmetic with common difference a. Any expression for any sequence which is not linear, which is not a n plus b, means this sequence is not arithmetic. What about the general term of an arithmetic sequence? For some arithmetic sequences, you may have the first term, the second term, the third term, but you need to go directly to the 100th term. So you need a general rule that expresses un in terms of n. For arithmetic sequences, to find the general term un, it's enough to write this formula. Un is up plus n minus p times d. Usually the arithmetic sequences, you are given u0. So if up is nothing but u0, then the formula, this rule will be reduced to un equals u0 plus n. If the first term usually is u1, you use un is equal to u1 plus n minus 1 d. Example, UN is an arithmetic sequence whose first term is U03 and whose common difference is to find U20. In general, UN is U0 plus ND. Consequently, U20 is nothing but U0 plus 20D. Replacing, you will get 43. Another example, UN is an arithmetic sequence such that U3 is 9 and the common difference is 2. Find U20. So to find U20, actually, you don't need to use U0 nor U1. You can use whatever you have, U3. So UN is UP, U whatever, plus this minus that, D, and consequently U20 is U3 plus 20 minus 3, which is 17. D, you will get 43. Now, what about the sum of terms of an arithmetic sequence? If you have an arithmetic sequence, let us consider, let's say, the first 20 terms of an arithmetic sequence. Is there any rule that you can find their sum directly without adding them individually? For sure, yes, and you have studied this last year. To find the sum of terms of an arithmetic sequence, it's enough to find the number of terms over 2 times the first term plus the last term. For example, find the sum of terms of an arithmetic sequence such that you are finding this sum from U0 till U29, and you are given that U0 is 5, and you are given that the common difference is 2. To find this sum, do we need to find the individual value for each term, then we add them up? No. So the sum will be the number of terms. Be careful here, the number of terms here is 30 and not 29 because we have started with U0. So the first term is U0, the last term is U29, and the number of terms is 30 over 2. U0 is given. Here we are giving you a remark. If you're starting with UI and ending up with UJ, if you want to know how many terms these are, it's enough to do J minus I plus 1. Now, UN is U0 plus ND, so U29 is 5 plus 25D, which is 63. Plugging in the values, you will get the sum 1020. We move now to the geometric sequences. A sequence is said to be a geometric sequence if the ratio of any two consecutive terms is equal to the same ratio or is constant. In other words, the ratio of any two consecutive terms is constant, not the difference, as in the case of arithmetic sequences. Hence, UN is a geometric if and only if any term denoted by UN plus 1 divided by UN is R, where R is independent of N. Equivalently, we can say that any term is R times the previous term, where R is a non-zero constant. Show that the sequence UN defined by UN equals 3 times 2 over 5 all to the n is a geometric sequence whose ratio is to be determined. So to prove that this sequence is geometric, it's enough to find the ratio UN plus 1 over UN. UN plus 1 means replacing n by n plus 1. Simplifying this, you will get 2 over 5, a value which is independent of n, and it represents the common ratio. Hence, UN is a geometric sequence with common ratio 2 over 5. Another example, determine the real number x such that x plus 4 minus 2x minus 8 and 3x minus 4 are 3 consecutive terms of a geometric sequence. Since A, B, and C are 3 consecutive terms of a geometric sequence, then for sure B over A as a ratio is exactly the same as C over B. Replacing the values or cross multiplication, we will get B squared equals AC. Solving for x, this quadratic equation, you will get x equals minus 4 or x equals minus 1. We have to be careful here. The first term of geometric sequence shouldn't be 0, otherwise all the terms must be 0. Actually, we should have said that these 3 terms are 3 terms of a non-zero geometric sequence. Otherwise, it's a special case and all the terms are zeros. That's a constant sequence. What about the general term of a geometric sequence? The explicit definition of the sequence. Any term un is nothing but up times r to the power n minus p. In the special case, when you are using the first term, which you usually have, u0, then un is u0 times r to the n. If you are using u1, then un is u1 times r to the power n minus 1. Example, un is a geometric sequence such that u0 is a 3 and the common ratio is 2. Find u10. Applying the rule, un is u0 times r to the n. So u10 will be 3 times 2 to the 10. And that's 3072. Example 2, un is a geometric sequence such that u2 is 12 and the common ratio is 2. Find u10. So to find u10, you don't need to have u0 or u1. You can use u2. You can use any term that you have. So un is up times r to the n minus p. So u10 is u2 times r to the 8. So it's 12 times 2 to the 8, which is 3072. Notice here we are getting the same answer. So for the same sequence, whether you are using u0 to get u10 or you are using u2 to get u10, for sure you will get the same answer, but you have to be careful how to use the appropriate rule. What about the sum of terms of a geometric sequence? The sum of n terms of geometric sequence is the first term times 1 minus the common ratio to the power number of terms over 1 minus r. Example, calculate the following sum. 1 plus 2 plus 4 plus 10, 24. Before finding the sum, you should characterize these terms. What about the terms themselves? 1, 2, 4, 8. What about this pattern? Characterize this pattern. This is clearly a geometric sequence because we are multiplying by a constant, which is 2. 4 over 2 is 2. 2 over 1 is 2, and so on. So the sum is nothing but 2, 0 times 2 to the 1 times 2 to the 2. So actually we are multiplying by 2. So it's the first term, which is 1, times 1 minus r. The common ratio is clearly 2. The number of terms is 11 over 1 minus r, and that's 2047. Now we move to another property here concerning the chapter sequences that you have studied last year, which is proving by mathematical induction. Consider the sequence un defined by u0 is a, un plus 1 is un over 3 minus un. Assume in this part that a, the first term, is 2. Prove by mathematical induction that the sequence is constant. Remember that to prove by mathematical induction any property, to prove any statement by mathematical induction, you need to go over 3 basic steps. What are the 3 basic steps in the proof with mathematical induction? The first step is to check the validity of the statement for the first level. And you're saying that prove that this sequence is constant, which means prove that un is equal to 2 for all n. So you check if u0 is 2. Then you go to the assumption step, where you assume that this statement, that the sequence un is constant, holds true for a specific level k. To finish the problem, you prove that the next level is also true. Let's go over these 3 steps here in this example. This is part 2. We go back to this part 2. Let me do part 1 now. So in this part, a is 2, and we're proving by mathematical induction that the sequence is constant. For n equals 0, u0 is 2, which is constant. In particular, this constant is 2. Actually, the question should be proved that un is equal to 2 for all n. Assume now that this statement holds true for a certain level k. So assume that uk is 2. To finish the problem, it's enough to show that uk plus 1 is also 2. Now, uk plus 1 is nothing but, we have to go back to the original definition of the sequence. uk plus 1 is nothing but uk over 3 minus uk. but UK is assumed to be 2. You need to use the assumption in this third step. Replacing UK by 2, you will get 2 over 3 minus 2, which is 2. So U0 is 2. You have assumed that UK is 2, and you have proved that UK plus 1 is 2. So UN is 2 for all n. And consequently, UN is a constant sequence. All the terms are 2. Assume in this part that the first term is 1. And we need to prove by mathematical induction that UN explicitly can be written as 2 over 3n plus 1. To do this by mathematical induction, we need to start with step 1, which is checking the validity of the claim of what we are claiming here for the first step. For n equals 0, U0, if you replace n by 0 here, you will get 2 over 3 power 0 plus 1, 2 over 2, which is 1. And U0 is A, and A is 1. So this formula, this statement, holds true for n equals 0. Now assume that UK is given by this formula, 2 over 3 to the k plus 1. To finish the problem, it's enough to show that this claim, this statement, holds true for the next step. That is, we need to prove that UK plus 1 is 2 over 3 to the power k plus 1 plus 1. Proof. UK plus 1, going back to the original definition of the sequence, is nothing but UK over 3 minus UK. But again here, UK is assumed to be 2 over 3 to the k plus 1. So you have to replace UK by 2 over 3 to the k plus 1 over 3 minus 2 over 3 to the k plus 1. Simplifying this and writing this as one fraction, you will get 2 over 3 to the k plus 1 plus 1. This is the statement which we wanted to prove. So the statement holds true for n equals k plus 1. And consequently, UN is 2 over 3n plus 1 for all values of n larger or equal to 0. Thank you.